Hello, this is Gotham Kara. As an industry senior director in the data storage space, I live at the center of R&D and product and operations with a comprehensive view of analytics and our digital factory throughout. I am volunteering again with ValleyML, this time as track chair for the AI Ops track, along with the Alok Puria. Many thanks to the ValleyML sponsors, our platinum sponsor Habana, our gold sponsors Efinix, Agimpulse, Cognifiber, and our silver sponsors, Applied Brain Research and Verta. A reminder to use the Whova platform for submitting questions, and do join the live Q&A immediately following the presentation. Now please welcome to the AI Operations track, Manasi Vartak, who is CEO at Verta. Manasi is not only the CEO, but she's also the founder of Verta, a Palo Alto-based startup building tools for AI and ML model management and operations. Manasi is the creator of ModelDB, the first open source model management system deployed by Fortune 500 companies. She previously worked on deep learning for content recommendation at Twitter and ad targeting at Google. Manasi is passionate about building intuitive data tools, helping companies become AI first, and figuring out how data scientists and the organizations they support can be more effective. Manasi has spoken at numerous research and industry conferences and has authored a course on model management. She earned her MS and PhD at MIT. Today, Manasi's presentation is titled A Reference Architecture for Operational AI. Please welcome Manasi Vartak.
Hi, everybody. Good morning. My name is Manasi Vartak. I'm the founder and CEO of Verta, and today I'm extremely excited to be speaking with you about operational AI and how we can implement it in your business. So let's get started. A bit about me. I have a technical background, did my PhD in databases at MIT, and my thesis was on model management and diagnosis. I built the first open source model management system called ModelDB that is now being used across Fortune 500 companies, startups, research labs, you name it. And at Verta, we work on an expanded solution set where we not only help teams manage their models, but also operate them at scale. So the topic of operational AI is one that I speak with customers a lot. And so I'm excited to share with you some of the trends that we see and what that means for your organization. So today's agenda is the following. We'll look at some trends that are driving AI progress. We'll then look at some of the hurdles that organizations are facing and how you can overcome them with adoption of operational AI. And then I'll get into the weeds on how to implement operational AI, touching on people, process, and technology, and going into detail on a reference architecture that we found to be a really great blueprint for anyone looking to implement operational AI. So with that, let's get started. As you would agree, AI continues to transform our world, whether it's as consumers of technology. There are smart devices in our homes, toasters, bassinets. We have self-driving cars that can get us from one place to another. We have robots that clean the floors, email clients that write emails for us, so on and so forth. And as we go into this AI-enabled future, there will hardly be any experience that is not enabled by some automation or intelligence. What that means for businesses is that every business is being redefined by AI. And in particular, the barrier for entry for upstarts is much lower because now what you need is a pre-trained model, some great UI, and you no longer need an adjuster to visit your home. You can actually do that through an app. And so every business is threatened to be disrupted by AI-enabled technologies. And so most organizations have spent heavily on data science trying to build those capabilities. However, what we see is that there are certain organizations who have, as we call it, crossed the chasm and have been able to enable their organizations to be AI forward. Think about Facebook, think about Google, Amazon, and so on. There's AI integrated into every customer experience, every business process in that organization. However, majority of teams find themselves in this chasm where they've shown success with a small number of use cases. Maybe they have redone the pricing algorithm, or they found a way to optimize energy usage for their company. However, going from a handful of successes to running the whole organization on AI has not happened. And so there are increasing questions about how much are we spending on data science? Are we getting the return on investment? Why are we unable to stay competitive with this upstart who's rolling out a lot of automation? And so today I'm going to be talking about what it takes to cross this AI chasm and how every organization can successfully do that. So what is this chasm? This chasm is going from a handful of success stories to your whole enterprise running on intelligence. This is no different from the chasm that comes with every scientific breakthrough. We're moving now from the research phase to the productionalization or operationalization phase. It's no longer about researchers like me in a previous life who are reading a lot of papers, doing a lot of experiments, and coming up with this brand new model that is supposed to change the world. The truth is that our models have gotten good enough that you can now take a reasonably performant model and integrate it into one of these systems like a Google Home or the iRobot or a Tesla and make a meaningful difference. And so it's no longer about the accuracy of your model. It's about how quickly can you produce a model that's going to move the needle and how quickly can we get it out into our product line. Said differently, the challenge is no longer data science. The challenge is we now need to take the data science and turn it into software. And all the people that we've hired, the skills we've asked them to build are not aligned with this new reality where it's about scaling that innovation. It's not about building that innovation for the first time. Here's a screenshot from a paper that was written 5+ years ago. And this was from Google. And given that they are an AI forward enterprise, they saw this coming at that time and really talked about what it takes to build an AI-enabled product. And the key point I want to highlight here is that your data science or ML code, your model, so to speak, is just that purple box. There's a lot more going on around that purple box, which is essential to making an intelligent application or experience successful. And in order to cross the chasm, what teams need to do is to not only understand all of the boxes around it, but integrate with these boxes and do it in a way that's efficient and cost effective. Said another way, so far, a lot of the work that data science teams are doing, let's call it 75 to 80%, are really focused on this left-hand side box, where it's data science and ML. You're reading papers, you're using Hugging Face, PyTorch, TensorFlow, Scikit-learn, you name it. Maybe there's R libraries there. You're doing EDA. You're finding a model, you are tuning its hyperparameters, you're doing feature engineering, you work super hard. This is a 6-month process. But ultimately, at the end of the day, when you think about how this model gets used, it's just a function. You have discovered a new way to take data, to transform it in a really important way, but you just transform it, and then you produce a transformed data. And so if you talk to a software engineer on what a model is, they're going to say, hey, this is just a way to transform your written function. Excellent. For them to consume this model, the kinds of things that they care about are, can you handle errors? Do you have unit tests? Can I count on your model to do the right thing? Can you respond in a reasonable time? What about compliance? What about integration into our software stack? And so while we've focused a lot of our attention, efforts, and skills here, where we need to be is really on the right side. And in order to effectively do that, we need to reframe all of our thinking to go from data science to really software. So what does this mean? This means that a data science team needs to be aware of or potentially use a different set of tools. This includes getting familiar with Jenkins. You may not like it, but you need to be familiar with it. You need to be aware of APM, application performance monitoring, logging. You want to interact with the IT stack like Artifactory, like Twistlog, scanning systems. Now, I'll talk about whether data science needs to have these skills, but these are things that, from an architectural perspective, data science needs to be aware of. You will also need different skills of the team. Unless you want your data scientists to learn all of these components, you're going to need people who are specialized in software engineering, in site reliability engineering, DevOps, and then risk management. Ultimately, the metrics for data science teams are going to change. It's not how many new projects we started. It's about how many intelligent experiences did we enable? How many people are using the products that my group built? And how are we impacting the ultimate business metric? Digging in another level, this also means, from a financial standpoint, that you can't continue spending on data science hiring. You're going to hit a ceiling on how productive these people are going to be. You're going to have to invest in up-leveling your staff or figure out a way to collaborate tightly with IT or grow what are called platform teams. And I'll talk about this when we talk about operational AI. The next thing is that productizing data science is going to take priority over starting new projects. Process becomes important. Tools become important because you don't want to do this one time. You want to be able to do it hundreds of times without thinking too hard about it. And then we're moving from artisanal to industrialized. This is the same thing around the first time that you make a chemical compound, you do a lot of experimentation. But once it's done, then it hands over to commercial, where they figure out how to scale it, how to get it to customers, and so on. And then this also means that you need to be doubly aware of the real-world implications of the systems you're building. For instance, is it easier or harder to detect fraud when you're using AI to build your application? What are reputational risks? Suppose you make a prediction, someone shares it on social media. Are they going to take issue with it? And why might they take issue with it? And ultimately, you will have to explain your actions, at least starting with this decision was made by this algorithm, and there's regulation in the House floor as we speak that's being debated that would require every company to record what prediction was made by what algorithm and where that algorithm came from. And so as you scale your AI, the real world implications become front and center and something that needs pre-thought as opposed to dealing with it in an ad hoc manner. So here's the world that we live in. And this transition from data science to engineering needs to happen and needs to happen rapidly. Our philosophy on making this transition is that organizations must adopt what we call an operational AI mindset. And we've chosen those words deliberately. There are various words used to describe it, include operationalizing AI, productizing, and so on. And we chose this word for a few reasons. One is it's an active verb, so it's all about using the model. It's not about developing it. Development is important, but this is about use. This is also about integrating your model into the key business processes or experiences that you're delivering to your customers. And this also indicates that there is a different skill set that's required. It's operations and it's AI. So what does this actually mean? Operational AI means models are just a means to an end. They're important, but a lot more is required for business impact. And the interesting thing is, once you have figured out operational AI, you can actually go back to doing really interesting data science because now you have the means to roll it out to a really large user base or to show impact with it. It also means that there needs to be tight collaboration and integration with software. As we talked about, IT plays a big role. Productizing your data science work is the name of the game. And then our metrics change and they are tied to business value, such as intelligent experiences for customers, whether they're internal or external. So this is great. This is a framework that can be used. how do we go about implementing operational AI? And I'm going to cover this from the lens of people, process, and technology. I will spend a fair bit of time on technology and the reference architecture we've seen work really well for operational AI. All right, so let's start with people. If you think about how your software organization is structured, you'll find that there is some core infrastructure. This might be your IT team. Then you have product development teams. This might be your web, your mobile. If you are, say, an insurance company, then it's going to be the people who build your claims processing. It's the people who build your call center software, so on and so forth. Let's call them product development teams. There's an app platform team that is tasked with supporting everything that the product dev teams need. So this would be someone who is on call when your application goes down. There are a number of SREs, DevOps specialists who work here. These are also the folks who enable Jenkins for you or other DevOps tooling. And what these teams together enable is that they enable you to build applications that drive your business. We see a similar structure on the data side. Data drives a lot of our businesses. You have data engineering teams that are responsible for writing large ETL pipelines that are going to take data from your operational systems, move it to warehouses, so on and so forth. There's a data team that supports all the infrastructure. So these are people who manage your Aurora, your MySQL, your Postgres, maybe they manage your Spark, and so on. And so these are the people who are really responsible for data ops and making sure that the data that's being used in the organization is high quality, it's constantly upgraded, it's fresh, all of those good things. What we found is for data science or AI to cross the chasm, you need a similar team structure that is going to help you to get your work out there. And we call them the ML platform team. You might already have a team like this that sits within IT. Sometimes it's a team that's within IT, but separate and dedicated to ML. What we found is you need a small set of individuals whose mandate is to assemble platforms that your data science and ML teams are going to use. And they also are your first line of defense once other people start using your models. So these people are on call if a model is not working as expected, and they will ping data science. They're not going to solve your problems for you, but they're going to provide tooling and infrastructure to make your jobs easier. And we found that the presence of an ML platform team usually indicates how quickly or effectively an organization will be able to cross the chasm. And so we highly recommend, if you don't have a platform team, finding folks in IT who are going to help you with that, or growing AML platform team. And you don't need hundreds of people here. The tooling in ML is getting better every day. And so with just a handful of people, let's call it 4 or 5, you could actually have a robust way in which you can operationalize your models and do it with peace of mind, knowing that if something doesn't work as expected, someone has the ball and they are going to catch it and they're going to let you know if you need to intervene. So that's on the people side, invest in platform teams. The second one is on the process side. Before you cross the chasm, it's okay for AI to be done in an ad hoc manner where everything is bespoke or artisanal. When you want to cross the chasm, it needs to be standardized because you need to have a lot of confidence in the processes and the models that you're putting out there. And so now is the time to implement best practices. How do we hand off from experimentation to operations or implementation? How must our model code be structured? What tests must be written? And absolutely, your data science team needs to do these things. You can't expect someone else to rewrite their code. You can't hire good people to do that. What are naming conventions? Who owns these models? What is the approval process? Does risk need to give you their rubber stamp of approval? Is it your IT team? Is it just your VP of data science? Whatever it might be. And so how do we hand off from we're in the experimentation stage to, okay, we're ready to use this more widely? Once you do that, you also need to figure out best practices for how do you serve a model? Do we need to define a model API? What kind of SLAs are we signing up for? How quickly will we respond? Those types of things. Who is on call if something goes wrong with this service? And this is extremely important for real-time AI, where you cannot wait for an hour for someone to respond to you. For batch systems, the bar is very low, but the AI of the future is real-time, and this is where you need to be. What's the procedure for promoting models to lab to staging and then to prod? And these tend to be different. The people that can promote a model to dev are not the people who can promote it from staging to prod. And so different processes need to be implemented here. And then once the model is running, what is our vetted procedure to monitor the models and how do we retrain them? So there's a variety of best practices that need to be implemented for you to use operational AI effectively. And the great thing about tooling, and as a tool builder, this gets me excited, is tools can either make it real easy for you to implement best practices, or they can be a hindrance. And so as you're looking at building or implementing existing tools, consider whether it makes it easier for you to implement these best practices or not. So that's a process. The last piece is technology. What we found is companies that have crossed the chasm have a dedicated platform for operational AI. And there's a variety of reasons for it. The main one I would highlight is that if you think about the computational requirements or the workloads that a system supports, those are very different in the experimentation or training phase than they are in the operationalizing phase. As we saw earlier, in the experimentation phase, the limiting factor is how quickly can I spin up resources independently so that I can use my scikit-learn, I can use my TensorFlow, and so on. When you go into the implementation phase, the things you care about are, is this resilient? Is this high available? Does it have hooks into Datadog or New Relic? A completely different set of capabilities. And so even if you have a training platform, you're gonna invest in an operational platform and either assemble it or buy it or build it, whatever makes sense for your org. So what does this platform need to look like? I'm going to walk you next through a reference architecture of a platform to support operational AI. This is something that we've learned over many hundreds of conversations, speaking with experts who have built such platforms, for folks who have used cloud services to build these and so on. And we'll walk through each box momentarily, and then you'll see what are the components necessary to run your AI at scale. All right, so we'll start from the left and make our way to the right. The first thing we start with is just model sources. Every data science team, and if you have multiple BUs, and every BU is going to use their favorite set of tools to build models, favorite frameworks. And often it's not a good idea to try to impose restrictions. In the creative phase, that's not the place to standardize. Creativity is not standard. And so that's where we found that giving data scientists the freedom to pick and choose their tools, their languages, their infrastructure is very powerful. You might be training your models in a GCP, Vertex AI. You might be deploying them on AWS. And so you need a translation layer, for instance. You might be using H2O to build your models. You might be using TensorFlow and so on. What matters is the ways that you operationalize these models need to be the same, irrespective of where they came from. It's just like having different flavors of ice cream. That's okay. You'll still package them into cones and then deliver them to customers. So that's your model sources. The next one is what we call the day zero of operations. This is your bare bones that you need to think about. And this includes things like, is there model storage? Where do I store the trained models? How do I organize them? How do I package them so that I don't need to worry about the languages used, the dependencies, and so on? Someone needs to take care of that. That's your packaging. Maybe you have optimizations you want to apply. These can be optimizations at the deployment level, or if you're running on specialized hardware, then it can also be hardware-specific optimizations. Then you need to serve the model. The serving just means that there's going to be, the model is going to run somewhere. You can make queries off it, and it will return you results. And then data deployment. Your model takes in data and it produces data. Someone somewhere needs to make sure that you get the data that you need. If you have features stored, then this is where the data deployment would be done. This is your day zero. This is the basic stuff you need to get one model operationalized. Hopefully, this will be running for a long time, and you need to care about day one. What is day one? Day one is making sure that your model goes through the same processes that regular software does, and it follows the same requirements. So you need to think about IT compliance. Do you need to be scanning your software for vulnerabilities? Are you integrated into DevOps systems? As I mentioned before, Datadog, New Relic, your Elasticsearch, whatever logging capabilities. Do you have a way, do you use enterprise authentication to be using to query your models? Do you have CI processes? Do you have CD processes? What about promotion between dev, staging, and prod? This is a place where a lot of best practices tend to come in. And do you have a way to deploy in a multi-cloud, multi-region hybrid scenario? So if you need to deploy in US East because of latency, or because that's where your customers live versus US West, then do you have the ability to do that? Those are the things that you are going to have to care about on day one, because IT is going to come knocking on your door saying, hey, you have a service. Service means software. I need you to figure out how to solve these problems. So that's day one. Hopefully you have all of that figured out. As you continue to evolve your model, you're going to run into the need for operational excellence. And this means once a model is deployed, you don't need to worry about constantly babysitting it, giving it more resources, making sure that it's meeting its SLA requirements and so on. You need to bake that in so that you have high availability, you have disaster recovery, you're monitoring your models to make sure that not only are they responding in time, they're responding with the right results. So this is where drift detection, ground truth mapping to your expectations is going to happen. And you're going to take some relevant actions depending on what your monitoring says. And so here we have day zero, day one, day two. For organizations to move to a software paradigm, you need to solve all of these problems before you can run your company on AI. Now, all of this process is great for maybe half a dozen models. There's still a few things missing as you scale to hundreds of models and model versions that are being used. And it's about management and governance. So if you have more than half a dozen models, you want to know where those models are in the life cycle. What is the business information? Because before you start a new project or another team starts a project, they should go look at if someone else has solved this problem and reuse as much as you can. This is where status and reporting goes in. If your exec wants to know, hey, what is our return on investment on AI? They should be able to answer that question. This is also where we look closely at the real world implications of our AI-enabled experiences. So this is where risk management comes in. Your governance council needs to put in some policies to make sure you're only using models in a way that they are meant to be used, or in scenarios where they're approved. There's privacy and access control questions that come in, enterprise security, responsible AI. So as soon as you get to scale, you need to start thinking about, how do I manage these? Manage essentially what is a fleet of models effectively, and how do I govern them so that any reputational risk, financial risk are minimized to our best ability. Then as long as you do all of these things, people are going to use your application. Don't underestimate the fact that someone needs to actually build services or systems around the use of your model. So you might make a prediction, but then your application team needs to interpret that prediction, needs to maybe explain that prediction to their users, and then have ways to react in case the model doesn't seem to be working as expected. All right, so that was a brief tour through the reference architecture that we found to be very useful as teams operationalize their AI and the integrations that you want to be thinking about ahead of time, as opposed to figuring it out as you go along. All right, so I covered off the people, process, and technology aspects of operational AI. I would like to highlight some results that we and peers of ours have seen in the market when teams have successfully implemented operational AI. So what can you expect? You can expect that the time to introduce new models into products is going to be reduced drastically. And this ranges from 10x to 100x. Anecdotally, we found teams that used to need 30 days to deploy models into new products have gone to 1 day. We also have teams that have great governance requirements, and now they can do that within just a couple of days. And so 3 months to a couple of days, we've seen that as well. You're going to find greater oversight over AI models. And this is crucial if you're in the regulated space, just knowing what models you have in use and making sure that you're accounting for the risk arising from those models. You're going to find greater business continuity and confidence because, well, you might have churn in your team, there might be a reorg, but the business is confident that their models are going to keep producing and producing in an effective way. You'll also find that you can enable more intelligent experiences. And we've seen numbers from 3 to 5x, and this ranges from new features that are AI enabled or features such as, say, search or recommendations getting significantly better because you have these processes to iterate on these models. And then the highlight for data science teams turns out to be once you're past the chasm, once you have the processes and tools, you can actually take on really ambitious work because you know that it's going to see the light of day. And so you get more funding, you get more people, you can do more ambitious work. And so this is kind of the paradigm of you need to go a bit slow in order to speed up and go fast. So with that, let me wrap up the areas that we covered today. Hopefully, I have convinced you that AI continues to transform the world. But for an organization to become AI enabled, they must cross the AI chasm. And crossing the chasm requires transitioning from data science to software. It's no longer about the models, it's about the software. And adopting an operational AI mindset is going to get you there. Build platform teams, build in best practices, and use a reference architecture to see around corners, to expect and plan for hurdles that you're going to encounter in your journey. And ultimately, this is all in the pursuit of bringing in true business value and making sure that our data science investments show great returns. So with that, I would be glad to take questions. That's my contact info. Feel free to get in touch. Thank you for your time, and I'm excited for the follow-up discussion. Thank you.
Hello, ValleyML Expo 2022 attendees. We are back with the live Q&A session with Manasi Vartak, CEO of Verta. We just heard really a wonderful talk, probably one of the nicest overview talks that I've heard in this area, plus really a very nice architecture proposed. Manasi, you gave us with a day 0, day 1, day 2. Very interesting stuff. This session, Manasi, thank you. You're kicking off the second half of our session today. In the first half, we had 4 wonderful speakers talking about the AI world in the factory, in the hospitals, in the field, in implementation, in operations, with the ML ops view from their perspective. Now with you in the second half of the day, we're transitioning to the more modern view. What is ML ops? What is AI ops? What is all of this ops stuff? And what are you and the other innovators out there doing to help all of us with that? So thank you for being a silver sponsor on behalf of the committee. And let's get into some questions. For the audience, again, remember to throw your questions into the Whova app, and we'll be monitoring that. All right. So So Manasi, let's start with a more detailed question regarding the whole architecture and ML ops. Model registry versus, this question came, model registry versus model catalog. Can you help us understand what's the difference between the two?
Definitely. So first off, thanks for having me. And I'm eager to answer questions on the reference architecture. It's an area that we have a lot of conversations with teams on, so please do throw in your questions. One that we get often is this one, which is registry versus catalog. Currently, teams might have a registry that tracks versions of their models. This is similar to, say, an S3 bucket where you have different files and you have named them V1, V2, V3. And while that's the bare bones that you need to actually get your model into production, it misses out on a lot of metadata that you need to make sense of the model, like what is your model API? How do I use this model? So documentation. What is the description? In what areas is this model approved for use? What are, say, gaps or areas in which the model works really well? Maybe it works well in high light settings. It doesn't work well in low light settings would be another example. The Google work on model cards is really great. And I think it has inspired a lot of work on model documentation. So that's another area that's covered in a catalog versus a registry. When you think about governance, who has access to this model? What approvals has it gone through? What data is being used by the model, such as, is it using PII information? Is it using PHI? All of those things are metadata that's associated with the model, but is not covered in the registry. And so a catalog is a superset of a registry that elevates just the binaries. You take the binaries, add a lot of contextual information to it, you add governance information to it, and then you come up with something that is accessible not only to software engineers or data scientists, but also to the governance and risk teams, to your executives and the broader audience.
Makes sense. As you said, it's the superset. The catalog is the superset of the registry, really right. Containing a lot of the key media information that's needed for any good system. Okay, great. Okay, we've got another question. Yeah, this one I'm also really interested in your view on. Data scientists, ML engineers, dedicated to different roles. From your experience and your view in this world, right, what's your recommendation as to the ratio or the numbers ratio between, how many of this kind of scientist engineer versus the other? How should people think about resourcing their teams?
Yeah. So what we found is, I would say, a few trends. One is we're seeing the rise of what are called platform teams. These are the people who are dedicated to standing up and maintaining the infrastructure that data science needs. So this could be a training platform, this could be your feature store, this could be your model deployment platform, and so on. So this platform team is dedicated to assembling that set of tools and then making it available. These are also the people who are responsible for maintaining a model in production. So if you have a real-time endpoint that is, maybe it's a chatbot, and so it needs to be responding very quickly and it goes down, that this is the team that gets paged in order to answer any issues. So that's a major trend that we see. The interesting thing is these platform teams do not need to be super large because the tooling in the ML space has improved so much. We've seen the ratios of, let's call it even 50 data scientists being supported by a platform team of just 3 or 4, because these tools have gotten that good. And once you have the right tools in place, it's a matter of how can you maybe build the right abstractions for your data scientists to use, or how do you configure your IT processes to help them be as effective as they can. So I'm a big proponent of put in tools as opposed to people. Have the people do the creative work, and things that are more mundane or repetitive should be done by tools. And that's where MLOps tooling can really play a big role.
Yeah, that's impressive. 50 to 3 or 4. That's pretty good. Yeah. And okay.
To be clear, there's teams that have ratios of one-to-one as well as one ML engineer. It's just given the current, especially given the current market conditions, I think a lot of people are finding those kinds of headcount numbers hard to justify. And so I think this is a great time to think about the tools and how do you do more with less if you can't hire all the headcount that you want to.
Right, right, absolutely, yeah, yeah. This is an interesting time as the economic conditions change, and how that will propel the ML ops tools and other tools to develop or propagate. Yeah, yeah, absolutely. Okay, so we were talking about this a little bit earlier in the break, and as part of your bio, you are inventor, creator of ModelDB with your PhD thesis work, and then that inspired you to move along and towards Verta. So the question that came is, ModelDB was one of the key inspirations of ML Flow. What is it, in your opinion, that excited you or made you believe that there's a market or a need beyond open source for experiment tracking?
Yeah, that's a really good point. So this was so many years ago when we started working on ModelDB, to be honest. So it's at that time, no one really honestly got the need for model management because we were still in the early innings. And a lot of what we were doing at MIT was evangelizing the need for what is now being called experiment tracking. And it was super exciting to build the first system that allowed for experiment tracking, think about the abstractions necessary to enable experiment tracking. But what I quickly realized as we were working with various users of ModelDB was we were currently in, I would say, the phase one where training was the challenge. And soon, as people got pretty good with training, the challenges would then move to how do we deploy these models and then manage and monitor them. And to me, that was the bottleneck to actually seeing value from all the resources that were being spent in AI and ML. And so that's what drove me to start with experiment tracking, but then focus a lot more on how do you make that usable. And a lot of the key elements of experiment tracking are still valid. Things like how do you provide lineage for a model once it's in production? How do you provide the same set of metrics while you're training as well as in production? And so the product that we ended up building drew from the best elements of experiment tracking and then applied it across a life cycle, which has paid off. But I do believe that we're going to see, as more and more teams bring models into production, we're going to realize that we need a different stack, as I was talking about in the operational AI reference architecture. We need a different stack. We need different integrations to make this really work. And I'm excited to see what kind of tooling, us and the broader community creates for it.
Absolutely, yeah. So I think you were a step ahead during your PhD days in thinking further long term, which is what you should be doing to come up with that. Yeah, and so now, as you said, a different infrastructure software stack is needed even more, right? So let's see how that develops. Great. Okay, next question. Your presentation touched upon the rise in real-time use cases for models. We have very strong competencies today in our analytical environments. What is it that's different about real-time infra that would not allow us to use the current infrastructure we have in place today? Maybe a little bit related to what you were just talking about.
Yeah. And I get this question a lot too, as ML teams are transitioning from batch to real-time workloads. And so just a quick primer, like when you're doing batch prediction, you have, say, millions of data points that you're predicting on. Maybe it's your whole customer database, but you also have hours or maybe a couple of days to process all of that data. And so your requirements are not about latency, they're about throughput. How quickly can I process these large amounts of data, maybe in parallel? And so that's on the bad side. When you go to the real time, there's a user waiting or a customer waiting for you to respond in a second or less than a second most times. And so you cannot use the same underlying infrastructure that you use to run really large batch processing jobs. You need things that are going to prioritize latency, and they're going to respond to you in a few tens of milliseconds at the most. A parallel I would draw is, for those who are familiar with databases, you have analytical data processing systems. So these are your data warehouses. They are meant to run long batch jobs or BI tools and so on. Then you have your operational databases. These are the ones that run your transactions. The ATM machine runs on it. Your checkout on Amazon runs on it. That's not the data warehouse. That's your transactional system. Mm-hmm. So this is very similar, where batch requires that the underlying infrastructure be optimized for throughput and large scale data, versus your real-time requires that it's optimized for quick responses. And so that's where we've seen that you need two different stacks to support it. The former for batch can be a more warehouse compute intensive type architecture. The other one more frequently is microservices. And if you're on device, that you take that to a whole different level. But it's very much the microservices type approach if you're doing real time.
Mm-hmm, mm-hmm. Absolutely. Throughput versus latency makes sense. Yeah. Yeah. All right. One more question. If you're currently in the process of standardizing some kind of model registry and tracking today, for context, let's say the user is using Databricks and Snowflake as two of the primary pillars in their ML development capabilities. So the question coming here is, does Verta, so this is about your product, does Verta work with Snowflake and Databricks? Do you recommend ModelDB or MLflow? Could you elaborate on those?
Got it. The big caveat here is you need to pick the tool that works for you. I'll give you based on my experience, what works and what doesn't. Both, you're going to need a data warehouse of some sort, and maybe that's a Snowflake, maybe that's a Delta Lake, whatever makes sense for you. Both of these tools are very good at doing, again, batch prediction, as we were talking about earlier. They're great for batch workloads. Spark is great for batch workloads. Your Snowflake can also run large scale. In fact, you can also run models on Snowflake, and that's something we support, and we have a partnership with them. So for batch, both are great, and you can run models using Verta on both of these systems. For us, what we find is when you go to the real time, that's where you do need a different stack, a stack that's different from a Snowflake, that's also different from a Databricks. And to referencing my talk is like, it's much more software, it's not data infrastructure. And so if you wouldn't run a web server on Snowflake, or you wouldn't run it on Databricks, don't run your models there, because it's not a data thing, it's software. And so that's where you do need specialized tooling, and that's the area that we focus on at Verta. So we typically help teams run real-time workloads on Verta, help them run batch workloads on whatever data warehousing system they have, and our cataloging and monitoring capabilities work across all of these disparate infrastructures.
Very good. Okay, so you've got the spectrum covered, the batch data warehouse focused, as well as the real time.
Yep. Exactly.
Very cool. So you've taken that full journey, actually, personally, right, from ModelDB, which you may consider more on the batch side, all the way through to the real time. Very cool.
It's the space changes a lot, so there's always something exciting to build.
Yeah, great. All right, we are at our 2:25 time end point. Manasi Vartak, CEO of Verta, thank you very much again. Really appreciate it. And thanks to all of the attendees for listening to Manasi's talk and joining us.
Thanks so much. This was a pleasure. Please feel free to reach out if you have further questions.
Great. Thank you again.
Thank you. Bye.
Speakers, our attendees, please tune in 5 minutes for the next talk. Thank you.